So in this lesson, we are going to look at custom vision. So there are a lot of models out there which you can train. Custom speech, custom vision are some of the examples. We will see a couple of them in the future lessons. In this, we are going to look at custom vision service. So the workflow is slightly different. We are going to train a model with something of our own data. So we'll be giving some images and telling the model this image is XYZ things. That's where the word custom comes into the picture. Slightly different workflow. Let's have a look into it. Before we get into the code of custom vision, let's review some concepts we have discussed in the very beginning of the training about training a model or fine-tuning a model, what that means and what it does. Because what we are going to do is train a model, an artificially intelligent model. We are going to train that model in this particular case. That's what we are going to do, or fine-tune it based on our requirements. Let's see some of the fundamentals. We already discussed some of these things in the very beginning. Let's review a couple of those things to make sure that we are in the same page. So the main thing we have is our model itself. So if you remember, the model is nothing but weights and bias. Weights and bias. Basically, nothing but some numbers which defines how each neurons connects to each other. We have seen different layers of neurons within the model. At the end of the day, that is what a model is all about. The weights and bias. For example, Llama 3.1 is an open weight model, which means that these numbers are open source. We can look at these numbers, download these numbers. So when we say model, it's all about the weights and bias. And of course, certain algorithms like activation function and things like that. But mainly it is the weights and bias. If you want to read more about it, read some article about machine learning, and I'm referring some good videos in the previous sessions as well. Now, so this is the model is all about. Model is just the weights and bias. Now, the model being weights and bias. In case if you want to change some of the weights or some of the weights we need to tweak a little bit, what we can do. So for example, some of these numbers we need to change. Not all of them, some of them we need to change. So in that case, the process is called training a model. In fact, the very first version of the model, say for example, v1.0 of the model, this version is created by some amount of training. The weights and bias is created by training a model. On top of that, we can fine-tune or retrain a model with new examples. So new data. So new data. So if you have new data to train a model, we can fine-tune that model. So what is the form of this new data? It can be any forms. For example, in our case, we are going to have images. So there is an image of something and we are going to name it or tag it or label it. Label, tag, it's all same thing at the end of the day. So this is a photo of Anand and this is another photo of Anand. We are giving so many photos of Anand. Why so many photos? Because the model needs to know how that particular object, this particular entity, looks in different angles and different variations and perspectives, if you will, the object is looking. And it needs to learn different ideas about that object. Just like you see the picture of a person and recognize that person later. Exactly like that. Now, there are 100 different angles and photos of Anand. Now, there is another entity with a different name or tag to it. What is that? Say it is a cat. So we are giving the photo of that cat and tagging it Billy cat. So there is another picture of the same cat from a different angle with a different perspective. Another one, again, Billy cat, all Billy cat. It is tagged correctly. Now this two information, so there are two information. One is the image and the tag, and the image and tag. Now this entire thing we are planning to, this is our new data. So this entire thing is our new data. So many images and corresponding tags, what that thing is. You can have more than one tag for a particular image. This can be Billy, this can be cat, Anand can be human, AI engineer, AI trainer, any kind of tag you can put for this entity here. Normally, in fact, maximum number of tagging, the better your data is. And this new data, so this is the new data. This whole tags and images, in this case, we are going to see images. There are other cases in LLM and things like that. It is all text in the form of question and answer and things like that. But for the example we are going to look at, it is all going to be images and tags. And this images and tags we are going to give to the model to train the model, to show the model the image of Anand and telling this is Anand. That's what we are going to do. We are going to show it an image and going to tell that it is this particular entity. Same we are going to do for other images as well. We can have any number of images and any number of tags, provided the tags exactly matches the image. And we should not incorrectly tag. For example, if you're giving the image of Anand and tagging it as a suspension bridge or something else totally different, the model will get confused and you can corrupt the model. The weights and bias can get corrupted and the model can get hallucinated. So clean data, accurate input is very essential for model training. In fact, one of the single most important aspect of model training is the accuracy of your input data. Very, very important. Doesn't matter what training you're doing, what model you're training, LLM or image recognition, speech recognition, doesn't matter. Accuracy of the input data is everything when it comes to machine learning. And the model will process the data. So it goes through all those algorithms we discussed, gradient descent, backpropagation, all the algorithms it will run internally and will change the weights and bias. So these are the weights and bias according to the new data. Sometimes it overrides some of the weights. Sometimes it tweaks the weights and bias such that the cost function, we have discussed about a cost function, is minimal for this particular data. Basically, that's all about training, minimizing a cost function. I'm not going to the details of it, but you can think of just like we human being looking at picture of certain things and recognizing as one entity. So that's what we are going to do first. We are going to train a model. We'll have a training endpoint. And then afterwards, the model, once the training is done, the model is a different model. So the model is a different model after the training. So the blue box is the trained model. Now what we can do is we can show a different picture of Anand. So this is a picture of Anand. This is a different picture of the Anand, and we give to this model and ask what is this entity. Then the model will spit out the word Anand. That's the idea. That's what we are going to do. At least that's what we are going to try. Again, AI, we are expecting a level of failure at all times. There is no 100% certainty. It is neural networks behind the scenes. Let's not forget that. So this picture right here is not any of these pictures. This picture is different from any of the pictures we have used to train it. This is a new photo someone has taken and giving it to the model. That's the idea. Same for Billy Cat. We are giving a new photo of the Billy Cat and it should respond with Billy. That's the idea. So this is what we are going to do with the custom vision. So the custom vision is all about giving custom images and tags to train the model. And once the training is done, we'll do an inference or analysis or whatever we call it. I would like to use the word inference because that's the correct artificial intelligence term for prediction. Prediction is not very much used anymore. It is the inference, but it's all same terminology, jargons, it's all same thing. So we'll be predicting. So we'll have a different prediction endpoint to use this model to predict the output for a new image. Now let's get into the code. So there are two things we will be discussing. One is image classification, which is kind of what we discussed. Then object detection. Object detection is very similar to image classification. It's just that it tries to find out so many objects inside a particular image. For example, in this case, if there is Anand as well as Billy in the same image, it'll find out both. Anand as well as Billy, if it is trained properly. So again, in the case of AI, accuracy is one thing for the data, like I mentioned. The second thing is the amount of data. The more the data, the more the training data, better it is. One is the quality of the data, another is the quantity of the data. So in our case, while our quality is high, we don't have much quantity. We have just 20 images for each tag, but we will see what we can do with it. If you are not getting the response pretty accurately, that's okay. We'll understand the concepts. So this is the library we are going to use. So make sure that you have a pip install for that. Let me see if I have commented that pip install. Looks like I have not. Let's see. We have it here. Let me copy this pip install so that you can use it later when you do it by yourself. So I'm going to comment it here. For this kind of things, I prefer Jupyter notebooks. Pretty straightforward and easy that way. The main reason I'm following this particular pattern is because in the previous training, we are using similar pattern. I don't want to change anything there for any kind of new learning that way. So we are good here. We are learning AI. So this is a pip install. Feel free to go with this pip install right here. If you're finding this particular binaries are not available or this particular libraries are not available, just one pip install will do all of these. So you should be good with that. The other ones you should be having by now. If not, check the previous videos. So these are the endpoints we are going to use here. Unlike the previous models or previous samples we've been using, we have two endpoints here. One is the training endpoint. Another is the inference endpoint or the prediction endpoint. So they call it the prediction endpoint. So those are the two endpoints we are going to create. Let's go to Azure Management Studio and create these endpoints along with the keys. I already have this endpoint created, so I won't be changing this code, but I'll show you how to create a new endpoint. Rest of the things will come back after creating the endpoint. So we are in Azure Management Studio. As usual, we are going to Azure AI Services. In this case, we are going to Custom Vision View. So these are the endpoints I'll be using in the training, which is already created. For the time being, we are going to create another endpoint, a new endpoint. So in our case, we create both prediction and training. So click on both. So create a resource group if you don't have. If you have, just select one of it. So I have just given a name. Looks like the name is okay. I think the name has to be unique. Probably you can put your name in front or something like that, then give a number. So I don't have any free tier available. So this is the pricing tier. This is where they charge you. The free tier is already used. So this is the prediction resource. The charges looks to be different. You can look at the details of the charges for the training as well as prediction. Normally, training is a very expensive activity from a compute perspective. So look at the charges. I have not really looked at the charges in detail, but trainings are normally very expensive. Review and create. So pretty straightforward, just like anything else we have created so far. No surprises. Hopefully the deployment will be successful. So it has deployed successfully. Let's go to the resource and it is here, right here. And if you click on it, you will see the endpoint. And if you click here, you will see the key which is required. So one of the things I would like to show you in the end is the vision portal, custom vision portal, where you can see all the stuff. We'll see that in the end. For the time being, we'll look at the images manually. Pretty much what we discussed: upload images, train and evaluate. Those are things we will look. So this is how you create the endpoint, and that's how we got these endpoints. You will have your own endpoints, so feel free to replace this as usual. Again, boilerplate things. Publish iteration name. So this can be pretty much any string you want. So this string we will be using for different purpose in the subsequent part of the code. So the first thing we are doing in this code is cleaning up the previous things, cleaning up the objects we have created in the previous iteration. We will get into it shortly, in the end especially, because this code I have written without any samples. I wanted to show you and explain how I have written this part of the code. So we'll get to this piece of it in the end. But what it's doing is it's just deleting what we have created in the previous execution of this particular code, which is coming up in here and subsequent lines. Also, I'll tell you why I have given it in the beginning instead of end. Normally, this kind of things should be given in the end of the code, but we have given it in the beginning. Apart from that, first thing we are doing is creating a project. So we need to create a project using this particular object, using custom vision training client. So we are using the training endpoint. So this is the training endpoint. Remember, we have two endpoints. One is the training endpoint and another is the prediction endpoint. So in this case, we are using training endpoint to create custom vision training client. And this is called the trainer. So what is the first thing we are doing with that particular trainer? We are creating a project within that trainer. So we'll see what this project is used for, basically to handle all those images and things like that. The training images and things like that, we are creating an object called project. What we are passing? We are passing a project name. Is it a good name? It should be a unique name. That's why we are passing a GUID, UID. It's a random string, a big random number at the end of the day. And that's what we are passing to this particular name. It has to be unique. So it's a UID. We'll see that. And we are creating two tags. One is a tag called hemlock. Another is a tag called Japanese cherry. Basically, we are going to give two types of images. One is the image of a plant called hemlock. Another is a plant called Japanese cherry. So we are going to give different images of these two items or these two tags to the model. That's what we are going to do. Why I have selected these two images? Pretty much that is what given in the sample which is associated with this particular SDK, and the sample images as well. I have just taken exactly as it is. But if you're adventurous enough, feel free to try anything and everything and see how the model behaves. But I was just lazy, so I have taken exactly as it is, and it works really well. So base image location, so location of the image directory and things like that. It's all trivial things. We are skipping such details. There is a array initialization, image list. Now what's happening here? So pretty much we are creating the image list dot append. So we are creating image list. We are creating a list of image with the content of the image and the tag. So the tag ID we have created here already, like so. And we are creating a list of images with that tag ID. That's what we are doing here. So what is this loop about? To understand that, let's go and see this particular folder and how it is organized. So everything is local. We are not using any URL here. So let's have a quick look at the location. So this is the folder we are interested in. So there are two folders. One is hemlock and another is Japanese underscore cherry. In the hemlock, we see a lot of images of hemlock. And if you look at the naming, it is underscore 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that is what this loop will do. If you remember the range function from the previous training, this will iterate from 1 to 10. And that's exactly what we need to iterate through all these images. That's what we are doing. We are taking one image at a time and tagging it with hemlock and creating this image list. Exact same thing we are doing with the Japanese cherry as well. So we are creating the image list with hemlock and Japanese cherry with the respective tags. And then what we are doing? Then we are calling this particular function, create images from files. This is an API, trainer.create images from files. Then we are passing the project ID and all the images. So this image list has pretty much everything, and we are associating that with the project ID. So this is supposed to upload the whole thing in the background. And what we are doing is we are checking the status. And if it is successful, we are continuing here. And if it is not successful, we are exiting. That is what this logic is all about. We'll debug this code, but I'm just doing a dry run in the beginning. Now what we are going to do is we are going to train the project. So trainer.train project. Basically, we are asking the model, train the model using that image. So we have uploaded the image with the tags. Now we are going to train it. So we have an interesting while loop here. pretty much a busy wait kind of while loop, not a great way to check the completion of something, but this is what it is right now for the time being. So we know that the training is going to be a lengthy operation. So we are checking the status is completed. If not, we are waiting for 10 seconds and retrying. Every time we are checking the get iteration and printing the status. So if the iteration status is not completed, we'll get here and wait for it to be completed. Not a great way to wait on something, but as I said, this will do for the time being. Now, once the training is complete, you need to publish that iteration. So iteration is nothing but that particular training and the model available after the training. So we need to publish that. So that's what we are going to do here. Publish that particular training iteration. And these are the things we need to pass it to that particular function, the project ID, iteration ID. Then this is where the name we have seen in the beginning, classify model. It's all different API parameters just to distinguish between different iterations, because you can have more than one project and you can have more than one set of images for a project, or that kind of permutation and combination it accommodates. That's why we have different types of objects here, projects, iteration, etc. So an endpoint can have different projects and a project can have different iterations. That's the hierarchy of things here. Not very important detail, but just an implementation detail. So this will be the endpoint qualifier for that particular iteration. And this is the prediction resource ID. Again, another resource we are giving. So once it is published, there is a trained endpoint that can make predictions. So the model is trained and we have a trained endpoint. So to use that, we are going to use the custom vision prediction client object and the second endpoint and the credentials we are passing to it. So this is a different endpoint. It's called predictor. And predictor we are using in the very similar way like we've been using other models so far. So for example, predictor.classifyImage. This sounds very familiar to us so far. Just like we are passing the project ID, the publish iterator name, which we have given here, and then the image contents to read. So these are the two things which will define that particular training we have done before. And this is the image content to be classified. So in this case, we are passing the test image right here. We can see that. So this is the hemlock and this is the Japanese cherry, two types of images. And this is the test image we are going to use, which is a hemlock, I guess. So this is a hemlock and our test image is a hemlock. So if our prediction is correct, this should return hemlock in the results. That's what we are expecting. So we have seen the code of custom vision or image detection. Now let's run the code and see how it works.